Hi, and welcome to the second unit of week 2 of our course From Media Computation to Data Science. Today, we're going to take what you did yesterday one step further. And let me put this into some context. When we talk about the digital transformation, the key word really is digital. That's what this week is all about. What does it mean, digital? Well, it's Latin. It comes from the fingers on your hand, but it also means numbers. As Yutka said, we're turning everything into numbers. So this is what you usually see when you talk about digitalization. We're turning an analog signal, which in theory has infinite resolution, into a bunch of sampled numbers. What's cool about numbers? Well, we can do math with numbers. And even if we cannot do it, computers are actually pretty great at it. Let me show you what it's all about. This is what they call the information pyramid, in which we talk about knowledge, the stuff that we know, that we recognize, but it's made up of information, of bits of pieces of information. And what we're doing is we're taking away the context until what's left is just numbers. Why are we doing this? Because numbers can be given to computers. So the process really is something that digitalization means everything is made up of numbers, but the second dimension is numbers have a context. They mean something. Today, we're going to see what happens when we exchange that meaning for something else. We're going to start by building a fun project that you already know from our first SNAP course, a drawing project. So we want to do something that sets the pen down or lifts it up depending on whether the mouse key is pressed. And you'll find that in the sensing category. Now you already know that when you want to distinguish between one case and the other, we can take a conditional, the if and else block. So if the mouse is pressed, we want to put the pen down, otherwise we're going to lift it up, and we're going to make the sprite always go towards the mouse pointer. We're going to do this all the time. So if I do this, the mouse is already following my pointer. And now, in order to draw, you remember, we need to turn this little check mark off. So I'm going to turn it off so the sprite is no longer draggable. Now if I start the script and I press the mouse button, I can draw something. I can draw a house, for example. And I can press stop and also clear it again. I'm going to attach something to clear it again programmatically, like whenever the space key is pressed, I want to be able to erase this. So far, so good. What does it have to do with the digitalization? Let's tweak this program a little bit. Let's choose an interesting number, an interesting color, red, and let's maybe also really increase the pen size to something really big so we can see what we're drawing. Now let's try this. Now it should draw something in red. Yes, I can draw something. And just to show you, let's make that sprite bigger still. So go to the looks category, and I'm going to change the size some more. So now I can see the sprite. You already know this from course 1. Here comes something that you don't yet know. Now we're going to add some context. We go to the sensing category and check out some of the blocks that are there. Here's a fun block. It's the microphone block. The microphone block gives us information of stuff that's picked up from the microphone in your computer. For example, the volume. if I click on this, I'm getting a number. And if I'm talking really loud, that number is bigger. And if I'm really soft, that number is less. Okay, that's loudness. There are other options in here. One of the fun options here is we can check out the frequency that is picked up by the microphone. So if I look at the frequency, there's a number, and it's a really big number. And what I want to do is, I want to find out the frequency as I'm whistling. Let me whistle into this. Wow, that's about 2,000 hertz. And what's about the lowest I can whistle? About 700. So what I want to do is, it's just numbers, right? I want to tweak these numbers so they're roughly at a scale in between 0 and 100. So I'm going to the operators, and first I'm just going to subtract 700. That was about the lowest. Let's check this again. I'm about at a 0. Let's check what's about the upper limit is. About 1,600, so I need to divide it. I'm going to roughly divide it by 20. Now let's check it again. Isn't whistling fun? I've just about a scale from 0 to 100. Now if you remember what Yadka showed you in the last video is that colors in Snap have a scale of 0 to 100. Get it? So now what we're going to do is we're going to make the sprite assume the color that we've computed here. So we go to the pen category, we go to the set pen hue block, and we drag in this function that we've just built. I'm going to put that also into the forever loop. Now see what happens. I'm starting it. The mouse follows my pointer. You can already see that it changes color. Let me whistle something and see how it changes color. Wow, I can control the color of my pen by whistling. Hey, how about I just draw a record? Let me whistle a song and draw a record. Let me try this. I'm running out of breath, but you can always kind of lift the mouse up. Let's continue drawing. Okay, now I've drawn a spiral by whistling. How cool is that? We've turned one information, the information of sound, into another kind of information, the information of color. Okay, how cool would it be to try to read it back? Let's give it a try. Remember in the last video, there's one magic block that Yadka showed you. You used it to create the pointillistic impressions of a photograph. It's sensing back the color. It's the at block. You can get back the hue at, for example, the mouse pointer. So what this does is we're looking at a certain pixel here, and we can sense the dimensions of the color, in this case, the hue. So now that we, for example, have the hue at the mouse pointer, here it's the hue of my block, we want to turn this back into a frequency, and this really is the reverse function of this one. Let's build the reverse function. So we're going to first multiply what we get here by 20. And we're going to add 700. Now, we just have to turn it back into whistling. So for whistling in the sound category, we have a block for that. It's called play the frequency or stop playing the frequency. So we want to play that frequency, and again, we want to do this while we're pressing the mouse, and we want to stop it when we lift the mouse button up again. So it's kind of the same reverse script as playing, as drawing something. We're also going to put it into the forever loop. And now let's try playing back Happy Birthday. Let's first move it out here and play it back. Wow, there's something wrong, and you can see here is something I wrote 290 instead of 20. So I can change this while it's running. Let's try it again. Did you see what just happened? It's kind of magic. We took away the context of what I whistled and turned it into a color. Now we're doing the reverse function, taking a color, crunching the numbers until they represent another frequency. This is something that we call encoding in computer science, or as laypersons would say, applied magic. So now we've got a picture that represents a song. Let's save that picture. We go to the stage, and remember, there is a fun block in the pen category that is called the pen trails. If I click on it, I'm getting the picture that I just drew. So I want to add this picture as a picture to my backgrounds. So my backgrounds are in the sensing category. There is a My block. In it, I can select the costumes. The costumes, it's a list. The backgrounds tab is actually empty. So I can use the list blocks, namely the add block, to add the pen trails to my costumes. So I'm going to click on this once, and now in my costumes tab, I have this picture. Okay, so now I should be able to record another one. This is kind of fun because you can actually draw your own instrument. Let's try drawing an instrument. So we drew another picture. Let's play it back. Okay, you get the idea. So another picture, we can also save this. We already got the script. Go back and add that also to the backgrounds. So now we can remove it again and check out whether the first one still works. So I'm clicking on the background to load the first picture. I'm not redrawing it. And I'm again playing it back. Oh, by the way, we can also play it backwards. So we can permanently represent one kind of information within another context. Hey, here's one more idea. When Yadga saw this, her idea was, what if we apply a graphic effect to this picture? Remember how in the looks category, we have these graphic effects. For example, we can have a ghost effect, but we can also have a color effect. And the color effect shifts the hue by kind of a percentage. So what if we shift the hue, for example, by 40? Look what happens. The colors changed. We shifted the colors. Now I wonder what happens if we play that back. Let's try it. See what happens? It's at a higher pitch now. So changing the colors by shifting all the hues also transposed the music. Isn't that magic? This is all about digitalization. We dig down until we can represent stuff as numbers, and once it's numbers, as Yatka said, we can do anything to it. We can change the numbers, and then we can represent it back in a different context. And as we exchange the contexts, something like magic happens. And only those who know the context know how to deal with the data. And that's the other secret. If somebody doesn't know the context, to them it's a secret. And this leads us to your exercise. You're going to do the same thing with a different kind of data. You're going to take your name, or a poem, or a slogan, or a password, and also encode that as numbers. Now your name is made up of letters. Now I'm just going to show you how to dig down to the numbers to get you started, and then it's going to be up to you. So, in order to get to the building blocks, remember on week 1, you can split it. For example, here is the name Alonzo. You can split Alonzo by the letter, then you get a list of letters. Now each letter, once you're at that point, that building point, each letter can be turned into a number by using the Unicode block and the Unicode of block. So if you have a letter, for example the letter A, you can turn that into a number. And if it's, for example, the letter capital G, that's going to be another number. Now you can do things to that number, represented as colors, hint. And you could turn that number back into a letter by putting it into the Unicode as letter block. And you get a letter. Well, that was an interesting letter. And that way, you too can change the context of information to encode information into data. This is it for Unit 2. I can't wait to see what you come up with, and see you in the next unit.